In this question, we've been presented with a situation where NH₃, which we know as ammonia, is being oxidized, right? So it's being oxidized and then it forms nitric oxide and H₂O. So, this is effectively, this is a redox reaction. But the main thing we're looking at here is balancing the equation, right? So in looking at this, one of the first things I'm going to do is I'm going to work on auditing both sides of the equation. I'm going to look at, well, to get it balanced, we need the same number of the occurrence of the elements on both sides of the equation. There aren't really any charge considerations here, so I'm not looking at charges really. I'm mainly just focus on the actual number of occurrence, right? So since the charges are obviously balanced, how are we gonna do this? So what I'm gonna do first is I'm gonna go through that process as I described. So I'm going to go through the process of auditing both sides. So I'm gonna look at the left hand side. So this is the reactant side of the equation. I'm going to look at the right hand side, so the product side, right? So the left hand side, we're going to look at the number of we've got nitrogen, we've got hydrogen, we've got oxygen, right? So NH₃O. And then similarly for right hand side, we're going to have NH₃O, right? Okay, so for nitrogen, on the left hand side here, so we've got it occurs once, right? For hydrogen 3 times, oxygen twice. Okay, on the right hand side, nitrogen occurs once, as you can see, hydrogen 2 times, and oxygen, well, oxygen occurs actually in both of the species that are the products. So it occurs in the nitric oxide, it occurs in the H₂O, so you can say it occurs twice. Okay, so as you can see, the main thing here, which is not balanced at the moment, is the hydrogen, right? So, and in this instance, what we have is we've got two. We've got 3 hydrogens on the left hand side and 2 on the right hand side, right? So how can we get that balance? Because it's not so easy as just putting some sort of number in front of just one of them. The way we're actually going to approach this is through looking at the lowest common multiple, right? So if we're considering 3 and 2, what's the lowest common multiple of the 2 numbers, right? So for 3, you're going to go 3, 6, 9, 12, right? For 12, it's going to do 2, 4, 6, 8, right? So as you can see, the lowest common multiple is 6. And given that, what I'm going to do is the side of the equation that has a 3, which is the NH₃. I'm going to put the coefficient of 2 in front of the NH₃, and the side which has 2, I'm going to put a coefficient of 3 in front of the species, which in this case is the H₂O, which has the H2. Okay, and when I do that, let's see what I'm going to get out of that, right? So so that's going to be 2 NH₃ plus O2 produces NO plus 3 H₂O. 3 H₂O, not H3. 3 H₂O. Okay. Now let's do our auditing process again. Let's take a look at what do we have now, given that adjustment we've just made. Now both sides, we've done something to both sides in this instance, so we can reasonably expect that on both sides of the equation, there's going to be some changes. But the main thing we were aiming for, right, was to try and get the hydrogens balanced, but that has side effects, right? So NH₃O NH₃O. So here we're going to have 2 times the nitrogen, right? 2 times the hydrogen. So that's H3, 2 times H3. So that's going to be 6, right? And oxygen O2. So that's going to just be 2. On this side, we've got for the nitrogen, it just occurs, as you can see, it just occurs once, right? Then for oxygen, we've got to do 3 times the oxygen here, so that's 3 plus this, so that's going to be 4, right? And for hydrogen, we've got 3 times H2, so that's just going to be 6. Okay, so now we've got the hydrogen balance, but then because of that, the side effect is that all the other ones are actually now not balanced, right? So so we need to look at how we can actually get everything to be we need to take a step in the direction of getting more balance, right? So what I'm going to look at is the nitrogen now, and the reason why I'm going to focus on that as opposed to focusing first on the oxygen is simply because the oxygen occurs on its own. You can see the molecular oxygen on its own. So when we leave this to the end, it's much more easy to kind of add a coefficient there without having all of these side effects, right? So that's why I'm leaving it to the end. So I'm going to focus first on the NO, right? Okay. So what I'm going to do to try and balance the nitrogen is I'm going to put a coefficient of 2 in front of the nitric oxide. Okay, so that's going to be 2 NH3 plus O2 goes to 2 NO plus 3 H2O. Okay. And then following that, we say, okay, well, for the left hand side and for the right hand side, we need to look at what's being produced. So for on the left hand side, for nitrogen, we've got 2 times the N, so that's going to be a 2, right? For nitrogen, 2 times. And here's the thing, there's not actually a need to go into too much detail on what this would be as far as working it out, because it is exactly the same as what we had before, so it would just be the same numbers, right? 262, right? Okay, so what we did make a change here, so that's going to affect the nitrogen and the oxygen counts. So in effect, for nitrogen, it's multiplied by 2, right? So got 2, which is what we were mainly aiming for, right? So for hydrogen, we've got similarly, we've got just it didn't affect that change didn't affect the hydrogen, so it's just the same as before. And then for oxygen, because we put the 2 there, it's going to change the number of the oxygen, so it's going to be it's going to be 2 times 1, so that's going to be 2 plus 3, right? So that's going to be 5. Okay, right. Okay, so we need to give some consideration as to how we're going to make this balanced, and one of the ways we can do this here is to consider, well, to get what's the multiplier here, right? 2 over well, let's divide the right hand side one, which is a bigger number, by the left hand side, so that's going to be 5 over 2, right? So that's actually our multiplier, which is obviously it's going to be 2.5. okay, so let's put our multiplier in and see what we get in terms of the balancing. So we're going to then get 2 NH3 plus 2.502, right? So that obviously what I'm doing here, if you can see that, so I've put the 2.5 as a coefficient for the O2 to try and get this to be to try and balance that. And so that's 2NO plus 3H₂O. Okay, and we've not changed anything on the right hand side just now, so it's gonna the values are gonna be just the same. So for right hand side, it's just gonna be the same. So NH₃O is just gonna be 265. Okay. If you look at the left hand side, you've got 2 times, so let me just put the values on NH₃O. So here you've got 2 times N, right? So that's going to be 2 H, so 2 times H is going to be 6. But here with the 2.5 O2, right? So you effectively got, if we were to write this as a fraction, what we're doing is effectively 5/2, which is what 2.5 is, right? So 5/2 times 2, right? So of course what happens here is that you're gonna the 2's are gonna cancel and you're just gonna get a 2, right? Right. So therefore no, wait, no, you're not gonna get a 2. I went ahead of myself. So obviously if this cancels, this is what you're gonna get, right? So you're gonna get 5. So it's going to be 0.5, okay? Anyway, yeah, so, okay. If we compare the number of these elements now with what we have here, you can quite clearly see that now we've got 265 NH₃O and 265. So this is balanced at this stage. However, there's an issue, which is the fact that our question specifies please use only whole numbers when balancing the equation above. But here we've got 2.5, right? So this can't be our balanced equation. Even though it is technically balanced, it doesn't adhere to these very specific conditions of balancing that the question requires. So further work is needed. What am I going to do to resolve this? Well, what we can see from visual inspection is that if 5/2, as was shown here, if 5/2 is multiplied by 2, right, we're going to get 5, aren't we? And 5 is obviously a whole number. So, but in this case, we've got an entire. If you want to keep it balanced, whatever we do to each individual component of these, like for example, this particular species, whatever we do to that, we need to do to everything else to keep everything balanced. So in multiplying it by 2, I'm actually not just going to multiply that by 2, I'm going to multiply everything by 2, okay? And if I do that, we're going to have, so for NH₃, it's going to be, let me use a different color. So for NH₃, we're going to have 4 NH₃ instead of 2 NH₃, right? So we're just multiplying everything by 2. And then for 2.5 O2, we're going to have 5 O2, okay? And then instead of 2 NO, we're going to have 4 NO. And instead of 3 H₂O, we're going to have 6 H₂O, right? And if you look at this very carefully and you're satisfied with the fact that all we've done is doubled the coefficients, if you're satisfied with that, it makes the process of the auditing much more straightforward. We don't necessarily have to do all the individual counting. We can just double these values that we have, right? So if we look at that, we've got 4, 12, 10, okay? And for right hand side, similarly, as you can see, all we've done is we've doubled this, and that's just gonna mean that for the NH₃O values, we literally just double everything. So it's going to be 4, 12, 10, right? And if you want, you can double check that, but that's basically what we've done. And as you can see, it's still balanced, right? It's still balanced across, you know, nitrogen, hydrogen, oxygen. But now we have no non-integers in as far as the coefficients. And because of that, we can say that we now have the balanced equation within the context of what the question is specifically asking, within the format question is specifically asking. So this would be, in this case, our balanced equation. So if we go back up here, we can put there. So this would be our balanced equation. Okay.